All right, welcome to the last lesson in Unit 2, Solving Linear Equations and Inequalities. We're going to combine what we know about inequalities and combine what we know about absolute value and figure out how to solve an absolute value inequality. So let's get to work on defining an absolute value inequality, what it means, and then get into solving it. All right, so absolute value. So we learned earlier in the unit that when we take the absolute value of 6, we know that that means we have two points that are 6 units away from 0. So that brings us to 6 or negative 6. Okay, so now if we take a look at an inequality, the absolute value of x is less than 6. So we're looking at which units are less than 6 away from 0. Well, the furthest I can go would be 6, and 6 units away brings us to anything up to 0. Or I would have anything that gets up to negative 6, and anything closer would bring us to 0. So, or anything that is less than negative 6. Okay, actually that would be greater than negative 6, right? Okay, so if we would put that one together, since it's between, negative 6 is less than x, which is less than 6. We're looking at all the values between negative 6 and 6, because those are all the values that are less than 6 units away from 0. We're looking at the absolute value of x, which is greater or equal to 6. We're looking at all the units, or all the values that are more than 6 units or equal to. So the two place it's equal is at 6 and negative 6. And if it's more than 6 units away, we're going to be going beyond those 2 points. So either x is greater or equal to 6, or x is less or equal to negative 6. Okay, so that's how we define these absolute value inequalities. And I would suggest that you keep that concept in mind as we start solving the inequalities. So let's take a look at our first example. The absolute value of 2x minus 3 is greater than or equal to 5. I'm just going to sketch out what we're looking at here. So if we're at 0, we're looking at all the values. Whatever's in here, we don't need to worry about that yet. But our absolute value is greater or equal to 5. So that means at 5 and at negative 5, those values will go beyond those 2 points. Okay? So now that we understand that, we can solve that. So I know whatever's in there, 2x minus 3, has to be, if we're looking at the first part, greater or equal to 5, or whatever's inside my absolute value brackets will be less or equal to negative 5. So then once we know that, we can solve both equations. At 3, 2x is greater or equal to 8, divided by 2, x is greater or equal to 4. Okay? So I can graph that one. X is greater or equal to 4. All those solutions that way. Second inequality we'll solve. Add 3 to both sides. And then divide by 2. Notice we're dividing both sides by a positive 2. So that keeps the sign in the same direction, or the inequality. It should actually be a negative 1. So I know x is greater than or equal to 4, or x is less or equal to negative 1. It's also equal to negative 1, it's anything less. So in this case, we've got this beyond situation, where it's beyond the 2 values. Okay? The second one we want to take a look at there. Anytime we have absolute value, just like with solving those absolute value equations, we need to get the absolute value brackets by themselves before we can do anything. So I've got a 5 sitting out here, so I need to subtract that 5. We still have a negative absolute value of x plus 4, less or equal to negative 8. So this is like a negative 1 being multiplied by the absolute value, so I divide by negative 1 on both sides. So I have absolute value of x plus 4 Now, since I divided both sides by negative, I reverse that inequality, greater or equal to 8. So now once I just have that absolute value figured out, I'm just going to sketch what we're looking at here so we have an idea. So looking at any value greater than or equal to 8. So anything more than 8 units away from 0. So that could be 8 or negative 8. And it can be equal or more away. Equal or more away. So this is a beyond situation. Okay? So if we take a look at that, we know whatever is in the absolute value brackets has to be greater or equal to 8, as we look at this first scenario, or they're less than or equal to negative 8. So if we understand that part, we can set up those two inequalities, and then we've got the compound inequality. We can solve both of those. So x is greater or equal to 4, or x is less or equal to negative 12. So it's equal. The values can be greater than 4. It's also equal at negative 12, which is not on the number line. So I can just add it over here. Equal there, and it's also less. So it'll be going that way. So those are our solutions graphed for that absolute value inequality. Okay, let's take a look at a couple other examples. Absolute value of 2x minus 7 is less than 9. So it's just absolute values. Let's sketch out what we're looking at here. So we know our values have to be less than 9 units away. So it's either at 9 or negative 9. Doesn't include those. And less than 9 bring us in between. So you see we have a between situation. All our values have to be between 9 and negative 9. So I can just set that up and say negative 9 and 9 are my boundaries. And I'm using my less than symbol. And then we're just going to put the 2x minus 7 in between because we know 2x minus 7 is between those two values of negative 9 and 9. We just solve this compound inequality now. Add 7. Left side, since I did it to the middle, I have to do it to the right side also. So negative 2 less than 2x less than 16. Now divide 2 to get x by itself. Dividing by positive, so signs all stay. And that leaves me with negative 1 less than x less than 8. My boundaries are at negative 1 and 8. Doesn't include them, so they're empty circles. That's everything in between. Okay. Next example. Let's get our absolute value by itself first. Add 4. Absolute value of x plus 8 is greater or equal to 6. Okay, I've just got absolute value, so I'm just going to sketch out what I'm looking at so I have an idea. So our absolute value of whatever's in there, we don't need to worry about what's in there right now. Okay, so we can kind of ignore what's in there, but the absolute value is greater or equal to 6. So I know whatever's in there has to be more than or equal to 6 units away from 0. 6 units away would take us to negative 6. So I can see that I have an or situation, okay, the beyond. So I know whatever's in there now, x plus 8, is either greater or equal to 6, or whatever's in there, the x plus 8, is less or equal to negative 6. So I subtract 8 from both sides. X is greater or equal to negative 2. Or x is less or equal to negative 14. So I take a look at the values that I got there. So x is greater or equal to negative 2 can be equal. The values that are greater go that way. X is less or equal to negative 14 can be equal at negative 14. My values of x are less than negative 14, so that's going to the left. Okay? Those are different examples that we can use as we work through it. Okay, we can generalize what we're doing with a general basic rule that always works. We're just taking what we've looked at and generalizing with a rule. So if you need this, you can put this into your notes. Okay. I prefer to understand the concept and apply it. But after we've done enough, we can apply a rule. So we've got an inequality. So let's say we've got ax plus b is less than c, the absolute value of ax plus b. Okay. So we know whatever the absolute value is less than a value. Okay. Just as long as this value is positive, because we know if it's a negative, it's not going to work with absolute value. These distances have to be positive. We know this one's going to be, if it's less than c, I'll just kind of draw this example here, 0. And I've got whatever value is here, and the opposite of that here. If it's less than c, that means it's going to be down to 0, and the opposite is true. So that's a between one. So it's between c and its opposite. Ax plus b, whatever's inside the absolute value, is between the values negative c and c. Okay? Keep in mind that we can replace that symbol with less or equal to the same thing. Okay? Now keep in mind, if we have the absolute value of x plus b is greater than c, let's generalize that. So we've got the values at c, values are then greater, and at its opposite, they'll be going the other way. So that's an or situation. Okay? So this is the or, whereas this first example was the between. Okay, or the and. And the or we also referred to as a beyond situation. And we know in that beyond situation, it's either greater than c, so ax plus b is greater than c, or if we're looking at this half, whatever the absolute value was less than the opposite of c. Okay? Same thing, the greater than, greater or equal to, there's no effect. Those can be replaced just as easily. Those are the general rules that we applied based on the rules of absolute value and solving equations. And now we know how to solve those. We've taken a look at, first of all, what those mean, and we've taken a look at many different examples. So you should be comfortable enough to try some practice. Bring any questions that you might have to class. And that should wrap up the end of the unit. Time to review and get ready for the unit test.